Is the screen visible?
Yes, sir.
Yes, sir.
Fine. So we'll quickly go through all these things. So whenever you are supposed to lay down a pipe network, the first step is that someone lays a pipe network for you, right? And this pipe network is laid depending upon the position of the roads, depending upon the position of the residential areas, depending upon the position of industrial areas, where and also having the demand requirement for all those areas. Then you fix the appurtenances. That means you decide where to put, where to install a pump, where to install valves, where to lay down the pipes and all. And finally you decide upon some of the design considerations. For instance, let's say you know that you have a uh, steel pipe, and you know that the maximum pressure a steel pipe can have is, let's say, 100 bars. Then you have to put this thing in the design consideration that the maximum allowable pressure through the pipe is 100 bars. So such kind of design considerations you have to lay down. And finally then you start with the pipe design part, right? So the main fundamental behind the design of pipes is that you need to ensure this, that if you have if you have a pump over here, this is, let's say, the whole city. Here you have a water tank, right? And from water tank you have a pump which will pump the water throughout the city, let's say. And here you have a residential area, and this residential area obviously needs the water, but that water needs to be supplied at a particular head, like at a particular energy level, so that all the residential areas, sorry, the residential houses in this particular area can use the water easily. So you need to maintain at this particular point a minimum allowable pressure, right? That thing is the main fundamental which is behind this design of pipes, that whatever pressure you have available over here, whatever head loss is going to occur while transportation of the water, this has to ensure that P minus head loss should be equal to the minimum P required at the terminal end. And this is what is written over here, that the terminal pressure should be greater than the minimum allowable pressure, and also the terminal pressure should be less than the maximum allowable pressure, and maximum allowable pressure will depend upon the type of pipe which you are using. Okay, then when you start with any kind of design, all the design methods which are there for the pipe design are all based on trial. There is no particular method which gives you a sequence of events which need to be followed and then you are done with the design. There's nothing like that which exists. So all you have to do is you have to use hit and trial. So if you have a very simple pipe network, then the order of events occurs like this, that you assume a particular pipe diameter which you are going to lay. You calculate the head loss through that particular diameter. You calculate the terminal pressure as I already told you, and then you check whether this terminal pressure is uh, matching with the design concentrations or not. If not, you again move back, you change the pipe diameter which you have selected, and you again start following this whole loop. Okay, till your design concentrations are matched with the terminal pressures. And when you are calculating the head loss, only one particular head loss is considered, that is the frictional loss through the pipe. And the frictional loss through the pipe can be calculated using two things: either the Hazen-Williams equation, the equation is already shown, or the Hazen-Williams monogram. Now, what thing is this about the Hazen-Williams monograms is that it gives you four different things. It gives you the discharge, it gives you the diameter of the pipe, it gives you the head loss, and it gives you the velocity. velocity of flow. All these parameters can be linked if you draw a line through this monogram. So let's say you are given that the flow through the pipes is, let's say, 15, a point over here. I'm sorry, a point over here 15, and you decide that the diameter which you are going to choose for the pipe is 150 mm, then you do not need to apply this particular formula. What you can do is you can directly put a scale over here. You can join these 2 points in a straight line, and you can just draw a line, and you will get to know that this is the particular head loss, which is written as 9 meters per 1000 meter length of pipe. Okay, and accordingly you will also get the settling velocity, which is around 0.85 meters per second for that particular flow, for that particular diameter of pipe, and for that particular head loss. So instead of using this particular equation for calculating the head loss, you can directly use the monograms, right? Monograms are the charts which provide link between different parameters. You can use the monograms and you will be having the value of the head loss. And from the using the head loss, you will calculate the terminal pressures, like the terminal heads, and you will see whether the terminal heads match with the design considerations or not. And we will study this thing using a numerical. Is it okay what I just said in those past 10 minutes? Was it okay?
Yes.
Yes.
Okay. So this is the numerical. I've just taken excerpts from the book. So you are given this particular uh, area which you are supposed to design. You have an overhead tank over here, right? Overhead reservoir you have over here. You are given different points. So this is point A, this is point B, this is point C, D. I know you all see, but I'm just mentioning E and F, G and F. You are given that the RL of the bottom of the storage tank may be